So hi, welcome in this beautiful city and a great conference. I'm really glad I was invited here. I will talk about functional programming in JavaScript. I should introduce myself. My name is Steigerwald and I'm a former Google developer expert for 3 years, and now I'm the JavaScript teacher. I maintain the Este development stack. It's basically probably the most maintained starter kit for universal web application, native application written in React, Redux, Immutable JS. It's something, it's not used only by me, but we have already 44 contributors, and that's all. So if you want to know more, just check it. So, the topic of our talk is the functional programming, and what's the buzz behind that? Because, wow, cool effect. So, there is on the right side, you can read some boring description from Wikipedia, which is not helpful if you don't see the code, and therefore I will show you some real code, because one code is worth of 1,000 words. And let me do a small prediction. I think the functional programming is going to mainstream for the next year, finally. It's still a new thing for a lot of people. I'm quite surprised. I had a workshop yesterday and I was asking how many people know the functional programming, and only 3 or 4 hands were raised. So that's why I decided this talk should be more basic than advanced. And the next reason why it's not super advanced is that I am talking only about the stuff I'm using in production. It's something like Facebook does with the open source. Facebook is open sourcing only stuff they are using in the production. So I think it's a good pattern. So what's happening? I think if someone is reading Twitter and the newspapers and etc., he must realize that functional programming is hot stuff. Even the old languages like C++, 11, and Java already has a lambda expression, and with the JavaScript and the BabelScript we had a lot of beautiful syntax, pretty useful for functional programming. Also, I would say the functional programming in the front end has been introduced by React mainly, because why React is different and why the other libraries are copying the React. The React has the functional roots. The same apply for Flux and Redux and Immutable and Lambda. So as you can see, you know now what about I'm going to talk. What is functional programming? It's not esoteric stuff, but it seems like esoteric stuff. I was previous year in the Google Developer Conference, and I tried to talk with my colleagues from Google about the functional programming, and they told me it's something academic stuff. It's not usable in the production. You know, OOP is here forever, and so it was my failed. I tried to explain why functional programming works, but I didn't succeed. Never mind. So just a quick list. Don't stay calm, because I will show you the real examples. So it's basically pure functions everywhere. Immutable values, composition over inheritance, records over classes, and it's all about the timing side effects. And as I said, it's no esoteric stuff. I think the functional programming is something like artificial intelligence. You know, it sounds cool, it sounds magic, it sounds strange, artificial intelligence, but when you understand how it works, it's just the boring, ordinary programming. Why functional? It's nothing new. It's a pretty old thing, but for some reason we forget what we have learned dozens of years ago. If you know, software is eating world is a famous quote from Mark Anderson, and because the software is driving everything, must be as good as possible, and the functional, it's proved, functional programming leads to less bugs, less complexity, more readable code, and more performance. So, is OOP really bad? Object-oriented programming? No, it isn't. It's just misused. You know, this is not should be supposed to be hate speech against OOP. You dicks, you did it wrong. No, no. OOP just was misused because nobody. We all, as developers, are self-educated guys, and for some reason, nobody told us about the functional programming can be so fun and so good, but it can be misused like OOP was. I like to think about object-oriented programming like about distributed state. And it's something inevitable. Distributed systems are ugly, they are hard, but they are here to stay, and that's all you can do with that. Nothing almost. So, in my slides there I leave that a lot of links useful for you to self-educate yourself. I highly recommend this beautiful talk about functional programming designed patterns from Scott. It's funny to listen to him because it's fun to listen to him because he is a very good speaker, not like me. And he explained all these details in a very simple way. So, how many of you are using design patterns in your code? And be honest, raise your hands. Well, that's a good thing. And do you like that? Do you think you are doing a good thing? Probably yes, because it was written. We are supposed to do that. But sometimes it's not as good as it could be. We have more options. So again, what's wrong with OOP in more detail? Basically, every method call on some instance is effectively side effect, and side effects are hard to track, hard to reason about, and nobody likes surprises in code. Surprise in a life is good, but surprises in a code is nothing good. So, inheritance, we were told that we should use inheritance, but inheritance is a trap because it freezes your design mistakes, and such a code is not flexible enough, and it's hard to change it later. Also, all these design patterns is just the simple principles, but the hard thing about design patterns is how to name these things or correctly, because we are masquerading as nouns, strategies, factories, commands. And if you think about design patterns as just simple functions, it makes much more sense. Naming stuff is hard. Yeah, you know. So, and that's how it looks like in the real application. So, it was a joke, but all good jokes are based on the reality, and this is the reality we have to deal with. React, I think it doesn't make sense to talk about the React in the details on the React conference, because the React is the reason why you are here. So I would just highlight some things. The people still are misunderstanding the React as the virtual DOM, and all the virtual DOM is just implementation detail. The most important thing about React is functional composition. And that's why the React components are written in the code. JSX is just the code looking like XML-like syntax, which is proved for hierarchical structures, but still is the code. And I really have no idea how the other libraries like Ember or Angular is trying to express functional composition in a HTML string tag soup template. Recently, I I'm watching the development around the Angular a lot. Recently I checked the issues, and there was something like, let's vote about the right syntax. So they are still trying to solve the best syntax for the misused HTML, and I highly believe that HTML should be just the correction of your application state, not source of the truth, but who am I to judge them? So, the React can be used in a different way. The best way I think React should be used is a pure React with immutable JS. Basically, it's just the regular React component with should component update method, which is used for all these immutable JS checks. I will show you examples later. And if you know the React new suggested stateless component syntax, it's beautiful, it's even more minimal, but don't use it yet, at least in Este, because in Este every components are pure, every component is pure. And the stateless components still doesn't have a way how to do the should component update check, and I was speaking with Sebastian, who is probably the leader of the React future, and he told me they are considering the should component update check. Maybe they choose different approach, and as I already said, Este is something I'm using in production. So it's despite the fact it's using the functional programming patterns, etc. It's something which is supposed to be mainstream and stable for production. So stateless components are nice, but not ready for Este yet. And now these examples. So if you haven't ever seen anything from functional programming, the simple and the most obvious pattern of functional programming is just function and pure functions without side effect. A little example here, I think it's obvious. Function, pure function. The most beautiful thing is it's really easy to reason about function. It has input, output, and that's easy. But we are using also dirty classes. And I love this example from the great functional book. I highly recommend to check it, Mostly Adequate Guide to Functional Programming. I love that style, how it's written. This is a quote from that guy. This is a super simple class, but somehow it doesn't work. It's the great demonstration how hard it is to thinking about state and its mutation. And you see a lot of code. And all that code can be rewritten in just this simple mathematic expression. So I think this versus this. This is class, base, OOP, as we thought to do that with a lot of abstraction. And do we really need such an abstraction? I don't think so. I think this is much more sense. And it also illustrates how the functional programming works. It's manipulation with data. And it's so helpful because it's so often for a programmer to be paralyzed by analyzing. And if we have function, it's hard to be paralyzed because the function is basically a task you must be done. It has input, output, and that's all. Next slide is about something also pretty familiar for you. Yes, we have a lot of array helpful methods. And the thing is, we don't need it. Because with functional programming, we would like to deal with the persistent data structures, which is collection which are immutable, and as the name suggests, immutable JS. It's the library from Libertarian, again, next good thing from Facebook. I think personally that Facebook saved us somehow, because I can hardly imagine what we do without the Facebook. and its influence to web development. We would probably hack to Angular or something like that. So, a lot of you probably know underscore and Lodash collection methods, and we don't need them anymore because almost all these pretty useful methods are part of the rich API of Immutable JS. I don't want to spend the time to explain how Immutable JS works internally. It's your homework, and I believe next speakers will describe it in more details. Just quick introduction. It's pretty simple. Instead of object, we have map, and every manipulation with the map create a new object, and the same is for array. So instead of array, we have lists, and I think this line is pretty important to know. When object is immutable, we can easily compare them, and that's the key for super fast React rendering without the hex. Immutable data structures. It could be hard to start with the Immutable JS without examples, and I have to say the examples in the Immutable JS. Documents docs is not as detailed as we would like to be, so you can just a second. Yes. Here. If you know how to use the Immutable JS in your application, just check the este, and for example, reducers in the to-do. So, how to update the nested structures, how to add things, how to find things, how to remove things, all these create, read, update, delete operations. I would highlight one thing, and it's the record. Record is basically replacement for class. I said classes are bad for most tasks we have, but it doesn't mean we should just deal with some plain structures. We want to have some structures named with some properties, etc., and they are called records. And the real life thing is important for server-side rendering when we need to revive state. Basically, these 3 lines convert plain JSON to record structure. As I said, because immutable structures can be changed, we can compare them just with a simple identity check in the JavaScript. So no deep differing costly algorithms, but just simply check, and this is how pure components work. Just this one method is optimizing your application without any details. The records have another super beautiful feature, and because to read the value from the immutable structure, you have to use the get method. But if your immutable structure is a record, you can use simple dot notation, which is pretty useful. So back to my presentation. So you have seen some immutable structures. Now you know why these immutable structures are useful for rendering. It makes rendering super fast. And now you see some diagram. And this is some diagram of, you probably were implementing something like that dozens of times. What's wrong with that? It's wrong what's wrong is that we simply doesn't know what happened, where, why, without the debugging, because that's how OOP works. But we can do it better with the Redux and actions. So instead of some magic method call, which change some data in some strange way, we encapsulate every change in action. It's basically design pattern command. And we have previous state, and we have next state. And beautiful thing, especially I like these two pictures because this is probably the most narrative explanation how upstate works. Your application is just movie. The movie consists of screens, and every screen is described by one application state. So here we have a previous application state, action with some payload which changes state, and the next new one state. So finally your application makes sense. The changes in your application. So you just have seen Flux design pattern from Facebook, and I am using the React implementation. I was using my own implementation, but I'm always happy when I don't have to write the code and maintain my own code, and I can use something better, and Dan Abramov did a wonderful work. There were a huge amount of Flux implementation, and basically always the same, just the API was a little bit different. And the important thing from this slide is the winner takes it all, and if some technology is winning, it's super hard to compete with such technology or library. I clearly believe the React won. You would have to make a 10 times better library to compete with React. And it's same for Redux and Flux implementation. Redux just won. It has great documentation, great implementation, so it doesn't make sense to use any other Redux implementation. And if you want to know how it's used in Este, just check. I would like to highlight that all components are pure, and I recommend you to strict top-bottom data parsing through the props. Some people asked me, isn't it, because if you are using the props, you have to pass the props through all parents, isn't it verbose? Maybe, but sometimes it's good to be verbose. You know, Harry Potter, it's the 7 big, huge books. It is verbose, yes, but it's also a good read, so no, it's not always that verbose is bad. So, the last line, side effects isolation in actions. Redux is synchronized, but our applications are asynchronized, and the state mutations and the side effects and all the dirty stuffs belong to the actions, because they are isolated in one place, and isolation means you have control. Next beautiful design pattern, functional pattern, is higher order functions, and in React we are using higher order components. It's basically component taking another component as a pattern. And this is yet another example from Este. I am using the decorators and higher order components to hook lifecycle to components. So it's something like relay, but for example, for Firebase, if you want to use the Firebase, you can't use relay. Maybe you don't need it because the Firebase has a pretty nice API. So that's how I'm using the higher order functions and components in the React. The last thing I would like to highlight is DI containers. I was using DI containers a lot, and if your application consists of a lot of small classes, DI container is must. But if your application is functional, you don't need DI container so badly. And because I don't have the time, again, I recommend you to read these 4 links. This is how we inject dependencies, is how we do pure DI, which means manual injections in Este. It's something like Angular services, but without the magic and without the string and without all that stuff. Just plain, straightforward injection of the stateful instances. This is not something I am using in Este, but this is a randomized functional composition in JavaScript on steroids. It's a very, very beautiful library. I don't recommend to use it right now because it doesn't work with immutable JS. Still, it's something you should know because this picture. Read why Ramda, you will understand. Conclusion. Mark Seaman, this blog, the first line, he is a great writer and he wrote an article about why functional programming is the next step when you are trying to do object-oriented programming as best as possible. Then you have to write functional programming. Time is up. This is a beautiful slide, but it's for your homework. Me, as a libertarian, I see the state in the programming and the state in the society as the same evil, and it's really beautiful how much similarities are between the state and the programming and the state and the government. So, thank you very much for your attention.
Cool. We have time for 1 question, so you can choose one.
One question?
Yes, 1 question and a short answer. So the first one, probably?
Let me read them. I like does functional programming scale from development cost point of view? Definitely. And what about definitely, yes. It's yes or no question, a yes or no answer. And Jake, it was great, and now is that. So, what I should tell more?
And on this positive note, we'll end the discussion.
I would like to say something about the combining 2 paradigms, OOP and functional. That's a good question, and because, as I already said, it's not like that OOP is always the bad. Use OOP when you have to deal with the stateful stuff. Sometimes it's inevitable. And you can see in Este, I have 2 places in all applications target where I'm using OOP and it's not misusing OOP. I believe we can discuss it later.
Exactly. So I think
okay.
you're going to be
Thank you again.
You're going to be in the VIP room. You can talk to him again. Thank you. Thank you, Daniel.